Welcome, code aficionados and digital daredevils, to a podcast that's about to dive deep into the fascinating world of WebAssembly. WebAssembly, or Wasm for the initiated, is revolutionizing modern engineering, pushing the boundaries of what developers can do. It's like a secret portal connecting your code to the digital cosmos. On this show, our hosts, Joel Moses, Oscar Spencer, and Matthew Yakabuchi, will be your guides to this virtual dimension, decoding the mysteries and unveiling the endless possibilities. So strap in for a bite sized adventure as we take off with WebAssembly Unleashed.
All right. Thank you, Tabitha. Welcome to WebAssembly Unleashed, your source for news and views about the world of WebAssembly. I'm your host, Joel Moses, and alongside me, my fellow WebAssembly obsessives, Oscar Spencer and Matt Yakabuchi. As you know, here on WebAssembly Unleashed, we'll always provide guidance and perspective on proposals, changes, and updates and what they mean to the WASM standard. And we'll be our normal fanboy selves, complete with catty gossip. So, I'm super excited about our WASM community guest today, but first, let me introduce my compadres, Oscar and Matt. Welcome, guys. How's it going?
Oh, it's going great. It's a beautiful day in the world of WebAssembly.
Yeah, I'm particularly excited about the announcement about the 2-month release cadence for WASI. I think that's really exciting. Whatever's ready is going to be released. Is that right, Oscar?
Yeah, so we voted on that, I believe, in the last WASI meeting. And so the thing that's exciting about it is that I think one of folks' biggest complaints about WASI is the release cycle is far too slow, taking more than a year in some of the 2 cases we've had so far. So I think saying, hey, we're going to be releasing every 2 months on this particular day. If it's ready, it goes. I think people are stoked and excited that we can actually iterate. So folks are pretty excited.
Yeah, dependable, reliable release schedules, release cadence is going to be big news.
That's really cool. And Oscar, anything else from the CGs we should know about?
Yes. So from the in-person CG meeting, it was a whirlwind of just approving proposal after proposal, advancing them to the next phase. Yeah. So I think we had custom annotations that went to phase 4, I believe. Branch hinting, I believe, also went to phase 4. JS string built-ins, that went to phase 3. I won't talk about that one and how I feel about that one. But yeah, we advanced a number of proposals. Some things that we were really hoping that we might get to vote on, but didn't quite make it. But still, I think there was a phenomenal progress for Core WASM. So huge community meeting. So excited to see where we take it from here.
That's really cool. All right. Well, I want to save enough time for our guest here, so I'm going to bring him on board. Now it's time to introduce our super special guest today, Joel Dice, Principal Software Engineer at Fermyon. Fermyon's been at the forefront of the WebAssembly community, both through Spin and Fermyon Cloud, and been a steady leader between the nexus between WASM and container technologies. In the last episode, we talked about the spec for Async, and now we've got the pioneer here who's actually doing the work. So, Joel, welcome. Always good to have another Joel on the podcast. Let's go ahead and jump right in. First, why don't you tell us a little bit about Fermyon, just to get started?
Yeah, Fermyon's been around for about 2.5, 3 years, and the vision is to make WebAssembly easy and accessible for application developers to get started with and to have success with. And so that's part of what Fermyon Cloud is about, being able to have a place to deploy your applications and share them with others and kind of grow and scale from there. And then Spin being primarily a developer tool to get you started in combination with templates for various languages. So whatever you're used to, if it's Python, if it's C#, if it's Rust, give you a good experience and a consistent experience for doing that development.
That's great. I like most people, my introduction to Fermyon was through Spin, and I know that Spin is now at, I believe, version 2.6 with WASI Preview 2 release features embedded in it. Tell us a little bit about what new WASI features have brought into Spin.
Yeah, well, we actually supported WASI Preview 2 before it was even a thing. We actually used some of the snapshot pre-releases and offered experimental support. And so now we're trying to keep it at the forefront. Part of what we'll talk about today is some of the WASI Preview 3 stuff that we're working on. And we want to make that available again in Spin as early as possible, at least on an experimental basis. And then, of course, once we ship it for real, on a stable basis as well. More recently, we've been, one of the roles Spin has had is to anticipate some of the things that we eventually want to standardize as part of WASI. And if you've heard about WASI Cloud Core, things like key value storage, blob storage, SQL, that sort of thing, the sorts of things that a cloud backend developer would expect to have available, making those interfaces available and anticipating the WASI versions, but making them available in sort of, a preview, sort of non-standard way first, get feedback from developers, is this what works well, what works doesn't, and then use that to feed into the standardization process. And so we continue to add stuff, things like message queuing support and that sort of thing with each release of Spin.
Yeah, I think back in the day, which is a hilarious phrase because this was like back 2 years ago or whatever, but back in the day, yeah, Spin was the only runtime that supported WASI HTTP, which was pretty crazy. So it was really fun to like see that before, I guess, like 2 months ago, whenever that actually went into preview 2. So before we get into all the fun async stuff, just like a little bit more about you. Word on the street is you did a clean room implementation of the JVM. What's that about?
Yeah, there's a long story there, and I won't bore you with the whole thing. But yeah, the bottom line is I'm a programming language nerd, and it sounds like you guys are too, to some extent. And so I was actually implementing a scheme dialect because I was big into functional programming. I read SCIP, and I was really, into the MIT school of thought there. Anyway, it turned out my work, we were heavily reliant on Java, but Java was disappearing from the desktop. It used to be built into computers, shipped as part of Windows and Mac and that sort of thing. But the honeymoon didn't last very long, and kind of, there were security issues and whatnot. But we had invested a lot in Java. So long story short, I converted my scheme virtual machine, the garbage collector, the JIT, into a Java VM, essentially. And I got our application, our desktop application, running on it very slowly, but it ran, and convinced my boss to actually let me kind of keep going down the path. And that eventually became the basis for our application. And so we could ship a single executable on a variety of OSs, including iOS, with ahead of time compilation using that mechanism. So.
Wow.
Yeah, see, now folks know who we're dealing with here. So now I think we can talk about the async stuff.
Cool.
Yeah.
So I think the biggest thing we want to know is just how did you actually get started in the idea of playing around with async? So very famously, you had your ISYSWASFA project. Yes. I sync, you sync, we all sync for async. How did that come to be?
Yeah, so late last year, well, I should say it started, I guess, when I started at Fermyon a couple years ago. I had very enthusiastically watched some of the recordings of presentations that Luke had done at the WASI subgroup meetings about his early thoughts on async and how it would work, and there would be a callback mechanism and various technical details. And I honestly didn't totally understand it, but I could see that there was a lot of promise in it. And, in hindsight, I think he would say he didn't totally understand it because it has evolved since then, those early proposals. And so it's been in the back of my mind for a while, but on the shelf because we had to ship WASI Preview 2 and we knew we couldn't get like the full vision of async in without pushing that back even further, to the theme of getting regular releases out the door. But it was always in the back of my mind. And as we were getting close to releasing WASI P2, which we ended up doing in January of this year, I started thinking about, okay, maybe it's time we can kind of take that off the shelf, start working on it again. And my first thought was, I was most interested in what the application developer's experience will be with a composable concurrency story that we want to deliver for WASI P2. And that's really what ISYSWASFA was about. Also just an excuse to have a fun name, I guess.
That's a fun name.
But it was really about what's the minimum I can change? What's the minimum that I can kind of just hack into these various foundational tools like WhipBindGen, Wasm tools, and Wasm Time to support at least at a high level, the developer experience that we want to deliver. And it turned out quite a lot, not quite everything, but quite a lot. And so I was able to kind of provide a proof of concept sort of polyfill, if you will, on top of the current component model that doesn't really have official async, and on top of WASI P2 that works for both Python and Rust, and I haven't gotten around to other ones, and I probably won't, because now I'm working on the real thing, which is based on a PR that Luke just merged into the component model repo on the WebAssembly GitHub org, which describes what real component model async looks like. And so that's sort of the whirlwind tour of where I was 2 years ago thinking about this, and then try experimenting with sort of a proof of concept / polyfill that developers could kind of play with. I want to emphasize that ISYSWASFA was never meant to be taken super seriously, and that's part of the reason the name is kind of silly. Is it's not meant to be like some sort of enterprise level thing that's going to be supported for a long time. Just a preview, if you will, of WASI Preview 3, so it's a preview of a preview, I guess, of that experience. And now Luke and I are kind of working closely together to deliver ultimately the real WASI Preview 3 experience.
And so as you've spent time working through all of this, implementing all this, and now implementing it upstream, obviously the specification has changed a ton. How do you personally feel about where the specification is now? Do you feel happy with it? Are there things that maybe you feel like should have gone differently in hindsight?
Yeah, well, first of all, I should say that even though that PR is merged, it's all subject to change. We still got a ways to go before we actually need to ship something, and it's probably going to be early next year at the earliest that I think WASI Preview P3 will be out. Again, we'll be doing regular 2-month cadence of releases for 0.2.x, so there'll be no shortage of new features being added to WASI. It's just that this big shift to P3 is gonna take a while longer. But to answer your question, yeah, I think it's going really well. I think Luke and I have converged. I've pushed back on a few things of him. He's pushed back on a few things, that I brought to the table. And I think, that interplay, that back and forth, and then of course others have been involved as well, has been extremely productive. And I think we're arriving in a place that I would say maybe Luke could do it on his own, but I couldn't have done on my own, so I feel good about it. The only thing I would say where that's been maybe a little bit of point of friction is I want to ship sooner rather than later, and Luke has a grand vision that he wants to kind of ship all at once, and so there's some details that I'm saying, look, Luke, can we do? I see how valuable that is, but could we ship that later? And so I think we're still kind of trying to arrive at consensus, as far as that goes when we ship stuff. But what we ultimately ship, we're very much aligned on. So,
this is really wild and exciting. I do want to rewind a little bit because you brought up, ISYSWASFA in exploring the developer experience. So what does it look like to the developer here? Is everything keyed off of language primitives that already exist, like async await, or is there something else that you have to do as a developer to key in on this?
Yeah, as much as possible, we want this to feel native and familiar to you. And so I would divide the set of languages that we're looking to support into 2 groups. One I would refer to as the stackless coroutine group, in which I would put Rust, Python, C# and JavaScript. All of them have async await, some variation on async await. The syntax can vary slightly, but it's pretty much the same pattern in all 4 of those languages. And those are the stackless ones. And so what that means, when I say stackless, I mean You don't necessarily have to preserve a separate call stack for each outstanding sort of unit of execution or fiber. There's all sorts of terms of art out there depending on which community you're talking about. But the basic idea is there you can sort of suspend to the heap. And then have all these sort of outstanding concurrent tasks be rehydrated, from the heap, and then suspended again as necessary. And then in the other group, you have Go and Java now with its sort of like Green Threads 2.0, and I'm trying to think what other kind of mainstream languages do this. I guess you could say C in a way. C kind of would want to preserve its stack and suspend using stackful coroutines. And I'm not sure where C++ is. I'm a little out of the loop with C++ these days. But the vision I want you to take away is, we've got stackless coroutines and we've got stackful coroutines. And for the stackless side, we want async await just to work. And all the combinators, like in Python, there's this task thing. You've got task.win each, or different ways you can basically say, okay, I want to wait for all of these things. Or in JavaScript, it's like promise all. You want to wait for all these things to complete, or you want to wait for the first one to complete of a group, or you want to wait for you want all of them. You want to convert a list of tasks into an iterator that yields results as things finish, essentially. So there's all these different combinators that you can use. And so this is turning long-winded. I'll wrap it up. But the idea here is that all that stuff should just work. And so any off-the-shelf library, like in Rust, we have Tokyo. In Python, there's Async IO. In C#, there's a whole standard system.net TCP or sockets, and system.net.http, etc. All that stuff should just work. And in fact, I just submitted a PR to support asynchronous system.net.http HTTP client in C#. And so, the bottom line is it should all just work. And then on the stackful coroutine side, Go routines should just work the way you're used to them working. So that's the goal. And the part of that is going to be taken care of by the binding generators for each of those languages. And then and they're going to kind of essentially take care of the details of connecting that sort of high-level native language experience to the low-level details of how the component model wants to essentially lift and lower functions. Those are terms that we use, that basically the ABI for communicating asynchrony to the host.
Got it.
That was a mouthful. Does that make some sense?
Well, I mean, it's no less a mouthful than is ISYSWASFA. By the way, I can't even say that without thinking of someone sneezing. Anybody else? Anyway, you're working on upstreaming a lot of the work from ISYSWASFA into the tools that we all use. What are some of the challenges in upstreaming some of the learning that you've done into something that is translating into the tools? In WASI?
Well, the stakes are a lot higher for something that's meant to be something that people actually use for real businessy types of things. I can't hide behind this. This is just an experiment. This is just for fun anymore. Like this has to be tested. This has to be, approved by. Code reviewers who know their stuff and are not afraid to call you out if you're cutting corners. It's a different level of seriousness that we have to take with it. The other issue I'm having right now is just that I personally have had to prioritize work on the .NET ecosystem over moving forward with async. So I've got some PRs that are just sort of sitting on the shelf right now, waiting to be submitted. So it's just time management. I think one of the biggest challenges we have in the Bytecode Alliance and in the WebAssembly ecosystem in general is we've got so many things we want to do: async, threading, TLS, all sorts of interesting, important projects, but limited resources to kind of devote to them. And so I'm feeling that squeeze myself. I know Luke is. He's like the grandfather of a lot of this technology, but he has. he's only one person at the end of the day. And so that's kind of what we face, with these kinds of projects.
Have you found technical challenges implementing some of this stuff? Because I can just imagine just the headaches that and the bugs and the debugging of some of this stuff.
Yeah, for sure. Well, one of the really cool features, and I think that really differentiates it from anything that's come before this component model async, is this idea of avoiding the colorless or colorful function syndrome. I don't know if you've heard of this, but you may have seen blog posts on Hacker News or whatnot. But people have complained, understandably, that especially in languages with async await, such as JavaScript and Rust and C#, that you've got colored functions. And so it could be, you could say the async functions are red and the regular functions that aren't async are blue. And so the issue of, okay, say you want to call a red function from a blue function, how do you do that? Well, there are answers to those questions, but it can be awkward, and it can be difficult for newcomers to learn and understand the trade-offs of, say, calling an async function from a synchronous context or vice versa. We wanted to minimize that in this design. And so one of the challenges, though, is we want to move the complexity away from the application developer and kind of move it into the host. And so that requires the host to be able to say, okay, I've got a component A and component B. Component A, component A here, component B here. Component A is importing a function async, and component B is exporting the same function synchronously. And we want them to compose, even though the implementations make different assumptions. This guy is expecting to be called synchronously. This guy is expecting to call that guy asynchronously, and every other combination. Obviously the trivial ones are sync to sync or async to async. Obviously that there's no impedance mismatch there. But anytime you've got async calling sync or sync calling async, you have the potential for this function coloring problem. And so we wanted to nip that in the bud. And the cool thing about this is the host is going to transparently take care of bridging any combination that you would want. And so you don't need to worry. It's not in other words, it's not part of the function type, like the type that, because that's what the component model is responsible for doing, is making sure the types match. When you want to compose two components together, the types need to match. The async versus sync is not part of the type. It's not going to show up in your WIT file. Instead, the host is going to take care of making sure that, okay, this async caller wants to call sync function, no problem. The sync function is going to block further synchronous calls in component B, but the caller, component A, is going to be free to make other calls to other components, and it's either going to be free to make additional async calls to that original component, and we just use back pressure to basically say, okay, well, that first synchronous call that you made earlier is still outstanding. I'm going to tell you, that this second call that you're making it's good. It's also outstanding, and it's not going to begin execution until the first call finishes, because this component B expects to only be called synchronously. And that way we don't have any sort of schism between like older modules or older components and newer components, where the older components were never expecting to be called synchronous or asynchronously, but newer components want to use async and not care about what kind of component they're calling.
So for sure. Yeah. And so something I want to get your take on, because it's something that I thought a little bit about. So we do avoid the what color is your function problem, but I sometimes wonder, are we introducing a what color is your component issue, where if I have a component that has a ton of asynchronous implementations, that's awesome. But if I have a component with a bunch of synchronous implementations, and someone's going to call all of those asynchronously and actually get none of the benefits of the asynchronous stuff because it's blocking all of the different calls, like, are we going to have this new issue where, hey, actually, I don't want to use this component, and maybe someone should mark that component as it's not really super async? Like, is this a new problem that we'll have?
It's a good question. Yeah, I mean, there's only so much magic we can do here because,
right.
the challenge is if a component really was produced before there was any concept of async in the component model, there's only so much we could do. Ideally, if we were lucky, that component would be safe to call in a reentrant manner from multiple fibers. But an arbitrary component written today is not going to have that shape and there's various technical reasons. There's this shadow stack where things are kind of when you need to take the address of an object, it needs to go on the shadow stack. And tool chains such as LLVM today assume there's only one shadow stack. And there's no reason that can't be changed in the future, but there's no way to retroactively auto-magically convert an existing component to kind of magically be reentrant, if that makes sense. Because even outside of the shadow stack, there could be global variables that could get clobbered, if multiple fibers were running concurrently. Similar to the issue of introducing multi-threading into Wasm. You can't just magically make existing modules thread safe, right? They're just not, they have no notion of atomicity, et cetera. So you're right. The idea would be that if someone's publishing a component that is not async and it's not reentrant today, hopefully, if it's a popular thing, eventually they will upgrade their tool chains and actually enable, with very few changes, potentially, asynchrony in future releases.
I'd be remiss if I didn't point out that in episode 8, our last episode where we talked to Luke, we had a long discussion about the concept of back pressure and some of the materials that Luke's been showing about back pressure and I think the presentation at Wasm.io, really, really interesting stuff, but it illustrates the breadth and depth of the problem really well. I have to ask, how far are we from a fully working implementation of async in Wasm time? And what would you say a fully working implementation has to have to be working?
Yeah, well, that's a good question. Partly because I'm not working on this stuff at all. I'm focused entirely on .NET right now. I'm hoping to get back to it ASAP. So it would start from whenever I get back to it. Or I am talking with other folks, especially folks who've been in the community for a while, helping me out on this. So hopefully it won't just be a one-man show anymore. So I don't. It's. The answer to that question kind of depends on the answer to some of those other questions. But I will tell you what's left to do that I know of, because I can concretely say that, is the big items are asynchronous destructors, which it's a very technical idea, but it's this idea that a component model has this idea of resources, and they become a fundamental part of the component model, encapsulating functionality in sort of an object-oriented way, and it's deeply ingrained in WASI right now, and will only continue to be so. And being able to asynchronously dispose of these things is very important. Like imagine you have a resource represented in a file or a TCP socket or something like that. You want to be able to potentially asynchronously dispose of that thing, potentially get any errors out of band, and so doing that in a way that fits Wasm time is. I've gone over this with Alice Crichton, who's like the Wasm time expert, on exactly what that entails, and there's going to be some refactoring there. The other big thing is, and I'm guessing that's going to take a couple weeks at least of just dedicated effort. The other big thing is cancellation, which is somewhat related to kind of disposing of resources, but it's basically telling the host or telling another component, I know I asked you to do this thing, but I don't care anymore, because maybe for performance, sometimes I'll send the same HTTP request to multiple mirrors, and just whichever one finishes first, that's the one I want. And I just want to cancel the other ones, right? Once I have an answer from one of them. Very, very popular technique in cloud computing. But we need to, we got a little bit of time left. We need to take care of that. And so that's a big piece. Again, I'm thinking having something that people can use end of this year sometime, probably having something that ships at the earliest early next year.
Okay, great.
Wild, ambitious.
Yeah, incredibly exciting. So with our last little bit of time here, I just want to know, what other areas of WebAssembly are you passionate about, or that you're interested in, that you're following closely? Like, oh, I want to see that proposal happen.
Well, the analogy to async in the component model is the stack switching proposals. Yeah, and there's plural, of course. I think there's some convergence now, but you've got Wasm FX, and you've got the bag of stacks proposal and whatnot.
Team bag of stacks or
yeah,
team
bag of stacks. I love the term. Yeah,
you made
like
Oscar so happy. Excellent.
Yeah, I'm a big fan of that. Like I told you I was a Scheme fan, and call with continuations and whatnot. That's totally my jam. So I'm really excited about all that, and I think it's going to be very complementary to what we're doing with the component model. So
fantastic. Awesome. All right. Well, with that, I'm afraid that's all the time we have for today. Unfortunately, a big thank you for Joel, the second Joel. Awesome to have another Joel. And as always, thanks, Oscar and Matt. It's a big application world out there. It's in time to unleash the power and promise of WebAssembly. So for Joel, Matt, Oscar, and myself, thanks for listening in. And be sure to hit the like button and subscribe for future WebAssembly news and views. Take care.
That's a wrap for our WebAssembly adventure, fellow Code Explorers. Thanks for joining us. And until next time, may Wasm be with you.